Ants have shown themselves to be incredible insects, living in large colonies and having extraordinary abilities. Take, for example, the bullet ant, possessing the most painful bite in the world. According to pestworld.org, ants can actually journey far from their own colony in search of food and find their way back using special pheromones. You could probably find ants in your own backyard because there are actually 12,000 different species of ants. And it's not surprising to find them at a local park either, because they actually live on every single continent except for Antarctica. In addition, this trapjaw ant holds the record for the fastest bug, as it can bite at 140 miles per hour or 225 kilometers per hour. That's the power of a car packed in to the jaw of an ant. While these abilities are all astonishing in their own way, what really distinguishes the ant from the average insect is its pure strength. There's actually a research study done on the strength of an ant. According to an article written by the Entomological Society of America, a specific species of ant can actually lift almost 5,000 times its own weight. Of course, they had to find out how this was possible, so the ants had to be taken apart. The scientists first anesthetized the ant by reducing the temperature of the ants. Then, they glued them onto a rotor. After completing the experiment with the ant, they found that the ant could actually lift 5,000 times its own weight. But how is this possible? The reason on why the ant can actually lift great amounts is based on its structure and small size. In the same study, scans on the ant's body uncovered the substance between the head and the neck. The neck was covered in some sort of soft material and the head was plated in a more hard substance. The transition between the two sections is very smooth. This actually contributes to the ant's imaginable strength. Because of the structure design, ants feel less friction when they lift objects. The second reason on why the ant is so strong is because of the small size it possesses. There are two sub-factors under this that we have to consider: surface area and volume. The ratio of these determinants can give strength to any small insect. According to ThoughtCo, the strength of any organism's muscle is directly proportional to the surface area of the muscle. The size is dependent on volume. The surface area is commonly calculated as length multiplied by width, making it a two-dimensional unit of measurement. On the other hand, volume is calculated by multiplying length, width, and depth, making it a three-dimensional measurement. The higher the ratio of surface area to volume is, the more an organism can lift in comparison to its own weight. The general trend is that the greater the volume in an organism, the greater the amount of surface area of muscles needed to support that organism. This information is important to the real world because engineers can use this data to construct micro robots to do heavy lifting in the future, but without the size of today's modern machine.